their screen. I'm going to take over. You're ready, George?
I am ready.
Ready. There you go. Today is our final day of presentations. You guys are wrapping up the semester for us. And then we celebrate after you submit your papers. Okay, so presentation expectations. We've gone over this with you in the past, but just as a reminder, presentations should be no longer than 10 minutes. And we have this what do we have? We have this arrangement set up so that, hold on, I have to stop sharing my screen for a little bit. We will use this hand raising. I'll demonstrate what you should see. So at 3 minutes left, 1 minute left, and time's up, you will see something like this. Plus, if you want to know what time and how much time you have left, you can look at my my box. Don't look at me, just look at the box, and you will see a timer on the upper right-hand corner, right? Just focus on that. And if you're wondering, oh, how much time do I have left? That's where you can look. And this is going up. So when you have 3 minutes left, it's going to tell you 7, all right? And so we'll do 3 hand raises. And the last hand raise, when your time is up, that hand won't come down. But at 3 minutes left and then 1 minute left, it will come down after 30 or so seconds. All right. So that's how that will go. And then let's stop this. What else? Slide deck is recommended, but if you have prepared other formats, that is welcome too. Audience will provide feedback via the peer feedback form, which I'll post in the chat when I finish going through this. The Q&A will happen after all presenters have presented, just so we make sure that there's enough time for all presenters to present. So take notes of the questions and the comments that you have for presenters, for your peers, so that you can have something to share afterwards. Presentations will be recorded for personal use, so that if you, for whatever reason, want a copy of your recording, you can ask us, reach out to us, and we'll clip that part out and send it to you. And presentations will be assessed on the following criteria. This is the rubric that we shared with you in the past, and this is what we will qualitatively be assessing your presentations on. All right. Today's presenters are all of you in this order, the order in which you signed up on Doodle, starting with Molly, and we will let you know when you're next. Yeah, so that you can just be ready mentally and with your slide deck. All right, questions? All right, Molly, you're next. You're up, and then Yanyi, you're next. All right, good luck. We're excited.
Sorry, Angela, how do we access that peer feedback form?
Oh, yes, I'll give it to you right now in the chat.
Thank
Give
you.
me 1 second. Yep. There we go. It's in the chat.
Can I get to get started? All right. Hi, my name is Molly Seebecker, and I am presenting on gender identity and emotional expression in popular music lyrics. Popular music has long been used as a barometer of American popular culture. Sorry. And in recent years, women artists have made substantial gains in chart rankings and ticket sales, so forth. So this led me to my research question. Is there an association between the gender identity of a songwriter or musical artist and the emotional content of the lyrics as determined by sentiment analysis methods? My data collection occurred in 4 stages. First, song titles and artists from the Billboard Year-End Top 100 from 1965 to 2024 were scraped from Wikipedia. Lyrics were collected from the Genius API. Corresponding songwriter information was collected from the MusicBrainz API, and songwriter and artist gender was collected from both the MusicBrainz API and Wikipedia. For gender, Wikipedia was used because their stylistic guidelines recommend using pronoun self-identification. I used a function that uses logical reasoning to identify each artist as either a band, a man, a woman, or a non-binary person by checking for keywords and pronoun usage in specific sections of the article. 2 dictionaries were created, one for artist gender and one for songwriter gender, and these were later mapped to the variables in the data frame, which contained over 6,000 songs. Once I collected the data, 2 patterns stood out. One was that most songs aren't written by one person anymore. The average number of songwriters receiving credits on a song has increased consistently over the decades. Second, most of these teams of songwriters are almost entirely by men. By team, I'm also including teams of 1 person. A music industry study found that only about 12% of songwriters are women. After pre-processing the lyrics and removing instrumental songs and songs written in a language other than English, I applied a transformer for sentiment analysis from Hugging Face. For each song, it created 6 new variables, a confidence score for each of 6 emotions: love, anger, sadness, joy, fear, and surprise. I also used the NRC emotion lexicon of emotionally charged words to create a variable for the rate of emotionally charged word usage in each song. Below are the songs that had the maximum confidence score for each emotion. So despite what the title of the slide says, these are not the songs that expressed the emotion the most strongly necessarily, but the songs for which the model was the most confident in that label. As you can see from the lyric excerpts, most of them actually explicitly included the name of the emotion or a synonym for it in the lyrics. The sentiment classifier that I wound up using was actually the second one I tried, because the first was more of a default and it did not classify the songs very well. It included a neutral category, and for example, it classified Before He Cheats by Carrie Underwood as neutral, presumably because in those lyrics, she just kind of matter of fact describes the actions that she takes against the car without explicitly stating that she feels angry, which I thought was very funny. But in the model I ended up using, it did correctly classify Before He Cheats as anger, so everything worked out. I focused my analysis on the subsets of the data that only had 1 artist when considering artist gender and only 1 songwriter when considering writer gender. I had to exclude non-binary identity because the sample size was too small to be statistically significant. For each explanatory variable, I ran a chi-square test to look for an association with the primary emotion of the song determined by the label with the highest confidence score. Both results were statistically significant. The heat maps of the standardized residuals between the expected and actual frequencies show the direction and relative magnitude of over or under representation in that category. Though only songs expressing surprise written by women songwriters met the threshold of ±2, I found the trend in anger of women being underrepresented and men being overrepresented potentially interesting because this aligns with ways men and women are frequently socialized. I also looked at artist-songwriter combination as an explanatory variable. Here I had to exclude some levels of each variable, namely male artists with a female writer and fear and surprise, because all of these had multiple cells in that row with frequencies below 5 and did not meet the criteria for a chi-square test. Though this association did not reach the threshold for statistical significance, I found some of the patterns in the data interesting. Again, songs by male artists with male writers are overrepresented for anger, and female artists with female writers are more underrepresented for anger than female artists with male writers are. I also found it interesting that songs by female artists with male writers are overrepresented in love songs. For the quantitative variables of the 6 confidence scores for each emotion, the primary emotion confidence score, and the rate of emotion-laden words, I ran Mann-Whitney U-tests instead of t-tests because the variables did not meet the assumption of normality required for t-tests. I ran all of these with both artist gender and songwriter gender for a total of 16 Mann-Whitney U-tests. 5 of them met or came very close to the threshold for statistical significance, all involving artist gender and not songwriter gender. Out of these 5 tests, the ones for which the average for women artists was greater than the average for men included the rate of emotion-laden words, just missing the technical significance threshold, the confidence score in the primary emotion, the score for fear, and the score for surprise. The caveats with the scores for fear and surprise are that those categories did have relatively smaller sample sizes and may not be quite as significant. The only test in which the average for male artists was greater than the average for women was the confidence score for anger. The first primary result is that from the chi-square tests, we can see that there are associations between both artist gender and songwriter gender and the primary emotion of the song, with men tending to be overrepresented with songs expressing anger and women tending to be overrepresented with songs expressing sadness and surprise. Second, though both artist gender and songwriter gender displayed associations with the primary emotion of the song, only artist gender displayed any significant association with the 8 quantitative variables measured, which suggests that the gender of the artist is a potentially more significant explanatory variable than the gender of the songwriter. Finally, anger was the emotion that showed the greatest statistically significant difference across both the chi-square tests and the Mann-Whitney U-tests. There were a few challenges with this study. First is potential limitations of the classifier. For a free classifier, it does have high accuracy rates in labeling emotions, but it has not been trained on figurative language in the ways that some AIs have been. Additionally, it is possible that it would show bias in text written in African American vernacular English, which could skew the results for songs that utilize AAVE. Second is that this research does not take into account the impact of genre, which may have its own associations with emotion or with artist or writer gender. I did collect genre information for each song from multiple sources, but I found that these classifications were always really granular and specific and frequently overlapping, like country pop and pop rock, in ways that would hinder creating independent genre categories for statistical analysis. Finally, the subset of songs that only had one writer skewed towards earlier decades because the number of songwriters per song has been increasing over the years. For future research, I think it would be particularly interesting to investigate how genre might interact with the variables of both gender and emotion. I would also recommend repeating this type of analysis with more songs that feature one artist and/or one writer, not only songs that necessarily made it into the top 100 of the year, which in recent years frequently feature multiple artists and multiple writers. Finally, I would be curious if there is an association between whether or not the artist and the songwriter are the same person and the emotional expression of the song. That's it. Thank you.
Thanks. Really great work.
Yanyi, you're next, and then Manu.
Hi everyone, my name is Yang Yi, and today I will be presenting Simplest for Knowledge Tracing, a comparative evaluation of transformer-based student performance prediction on the assessment dataset. Before we start, I want you to imagine a world where every student gets personalized help exactly when they need it. So today we will explore how models like Simplest are making this a reality by predicting student performance. Limits of personalized education. So as a former high school math teacher in New York City, I have seen how students struggle to understand math concepts. Students fall behind when they do not receive timely intervention. I also recognize the limits of one-on-one instruction to teachers. Creating handouts that meet the needs of students with different levels of support takes a lot of time and careful analysis of student data. And for that, we have one solution: knowledge tracing. So knowledge learning refers to the process by which machines or AI system model and predict how individuals acquire and master knowledge over time. So it is widely used in educational technology, for example, intelligent tutoring system and adaptive learning platforms to personalize instruction based on a student's progress. Literature review. So before this study, there were gaps in existing research in this field. So early studies use Bayesian models, which is important.
Got a new person.
Which is important but not suitable for today's large educational datasets. More recent deep learning methods like deep knowledge tracing have improved things but still struggle with interpretability and overfitting. The Simplest model is a notable advancement because it includes temporal features, but has not been tested on the assessment 2012 to 2013 dataset yet. Before we start, I want to introduce you to the dataset. It is the assessment 2012 to 2013 dataset. It is the dataset from an online platform where students can answer questions. It contains the information from the academic year 2012 to 2013. It includes 2.5 million interactions from 27,000 students working on 4,500 unique problems. It features temporal data with timestamps, behavioral metrics like correctness and hint usage, and estimated affective states indicating boredom, confusion, and frustration during problem solving. A brief description of the models. So this study evaluated 4 models. The DKT models acts as baseline and use a standard LSTM setup. The main focus of this research is the Simplest model. It uses a transformer design with self-attention and special temporal embeddings. The DKVM and model adds dynamic key-value memory networks, which the LSTM-KT model improves traditional LSTM methods with better skill and response encoding. We use a standard training procedure to compare the models fairly. We split the dataset into 80% for training and 20% for testing. All models trained for 5 periods of time. Here are the results of the study. The Simplest model exhibited impressive performance across all evaluation metrics, achieving an AUC of 0.967 and an accuracy rate of 90.89%. Its precision of 0.7630 marked a 6.9% improvement over the LSTM-KT model, making it particularly effective for scenarios where false positives have significant costs. However, the LSTM-KT model recorded the highest overall AUC at 0.9683 and a recall rate of 0.9568, successfully identifying 95% of at-risk students. This robust performance indicates that it may be the preferred option for early warning systems focused on comprehensively detecting struggling students. Here is a table of the performance metrics of all 4 models. As you can see, the LSTM-KT model has better performance on AUC, accuracy, recall, and F1. And the SEM+ model have the highest score on precision. Here are the bar plots that compares the performance of all 4 models, as you can see here. Error analysis. So the response time indicates student uncertainty, making it useful for real-time interventions. So the SEM+ model identified 4,599 negative cases, but have 210 false positives. So a review showed that many of the false positives were students who guessed correctly without mastering the concepts. This also caused that the timestamp was ruin and confuse the model. Discussion. The findings of this study have important implications for adaptive learning systems. The SEM+ model's high precision make it ideal for high-stakes applications like certification systems, where false positives are problematic. However, the LSTM-KT model's strong recall make it better for early warning systems to identify at-risk students. However, this study has limitations, including a significant class imbalance with 85% of the responses being correct, potentially skewing accuracy metrics. Not only that, the data on affective states was based on self-reports rather than objective measures. So here are some possible future research. Future research could explore hybrid models that combine SEM+ precision with LSTM-KT's recall, optimizing both metrics. We can also incorporate multi-model data like eye tracking or voice analysis. It may also improve predictive accuracy. Thank you.
Thanks for your presentation.
After that is Marley.
I'm sorry, just a quick question.
Mm.
So I'm just submitting the peer feedback form at the end of each presentation and then hitting submit new response and starting again with the next person?
Yes, correct.
Great.
Yeah, good question. If you do have questions you want to ask after all the presentations, do jot them down somewhere else so you can refer to it, because I don't know if you can have access to these forms after you submit them.
Hi, can you see my presentation?
Yes. You're not on the first page though.
Oh, yes, sorry.
Yep.
Can you see my first page now?
Yes. Yep. Alrighty.
Hi, everyone. My name is Banu. I chose the subject of studying mortgage prepayment risk modeling using methods, machine learning methods, primarily logistic regression and Cox proportional hazard model. My research, so basically this is my first slide. Prepayment risk is really the risk of paying down a mortgage earlier than its maturity. This risk is tracked through during mortgage-backed securities that are maintained by institutional lenders who buy the mortgages, and because they want to project cash flows, and they need to know when mortgages prepay potentially in the life cycle. So it is dependent on several features, basically interest rates, borrower behavior, and economic conditions and macroeconomic factors. Some of the earlier research that I read about includes the Dunn and McConnell about Black-Scholes option pricing framework, which says the strategy is that borrowers have a call option. When they have a call option, it's primarily due to the interest rate movements when mortgage rates are essentially lower than the original interest rate. However, there are other factors and interactions of those, and machine learning really is used more recently to model prepayment risk over a large volume of loans over 120 million, et cetera. So my study focuses on the single family loan level data set, which is the Freddie Mac's website. I downloaded all historical data when I got access to those. However, my study is really based on 3 vintages, which is the 2013, 2019, and 2020 files. These are just the sample files of 50,000 loans from the original historical data. So here's some really some content. So this is really my so the Freddie Mac has 2 data sets. One is the origination loan data set, and another is the servicing loan data sets. So the origination loan is just origination of new loans every year. And the servicing includes all monthly variables related to the loans portfolio and also the life cycle of the loan tracked throughout the years in monthly statuses, pretty much. So basically my EDA, I took I created scripts for the 3, and then I looked at 30-year fixed rate mortgages and merged these 2 files, and then excluded any null values. The script also merges HPI and unemployment rate from the FRED site. SATO is the spread at origination. It tells us how the loans have been originated, specifically around the original interest rate on the portfolios, and also how they could potentially behave down the road in the life cycle of a mortgage. So here's some other variables that I considered part of my portfolio, my actual data set. I also have some key summary statistics here around debt to income ratios and the standard mortgage variables, which is also the credit score profile of the 2013 vintage file. So it's just summarized here. Let me keep going. So I created some EDA plots because I wanted to understand really what was going on with the time frame. So I have a few plots, so I'll just skip over them. This one is actually the median credit score to the mortgage rate incentive over time. Here, the time plot reveals a decline in median credit scores during 2013, followed by a recovery in 2014. The Federal Reserve around that time announced taper tantrum, pretty much a quantitative easing program, leading to a sharp rise in interest rates. So therefore, that's where you see the here, the borrowers that originated higher interest rates had greater incentive to refinance prior to the higher interest rate increase subsequently with a drop in interest during incentive during the October 2013 timeframe. So a couple of other plots here. I'm going to skip through those. This one is the current actual UPB over time. It's the unpaid balance. Here, the figure shows standard prepayment stable activity first, but then you see a steep increase in 2014. This significantly reduced prepayment activity and also new loans being originated around that time frame. Not sure why there's a spike of new loans. Potentially could be market trends of more people getting access to loans. In the market. So here it is unemployment rate and home price index to track that. You can see the unemployment rate fluctuating between, although there is 12% actually quite high in 2020, that right before COVID timeframe. So that's kind of nice to know. Some other plots here, jumping over these unemployment rate and home price appreciations. I also created lag variables because primarily speaking, the GARP suggested that lag variables are something that financially in loan modeling. It's primarily used to understand how the behavior sets in 2 months following or 6 months following what actually happens back in the time frame due to market indicators moving in certain directions. So here's some other plots. I'm just swinging through these a little bit. So these are my set of plots. I repeated these plots for 2019 and 2020 as well, but I did not include them in this PowerPoint. It will be in my Word document so that I can look at the different changes in data. So here are some of my variables that I used: credit score, original UPB, LTV, DTI ratio, interest rate, original, SATO, HPA, which is home price appreciation. So all the plots you saw, these are the variables that I used related to those plots. The prepaid and the loan duration are 2 variables that is needed for Cox modeling, and so I created them. There's a column called zero balance code on the loan origination servicing file, which says that on the month that some record prepays, it is usually turned to a 1, but otherwise it's 0. So all the other records will be stated as a 0. The Cox model is actually used today as well as in the past. It is a model that is the equation is given above. I use the Lifelines implementation in Python. It is given by the baseline hazard function, and then also the exponential of the predictor variables and the estimated coefficients. With this model, we don't really have to specify the hazard baseline function and how it is arrived at due to the way if the assumptions hold that there's no changes of the covariates with respect to time, which is actually checked based on the assumptions check, one of the assumptions check for that model. If the assumptions fail based on that mathematical check, it means that variables vary with time, and so therefore you have to fit a different model. So my understanding was related to studying that is using this model first and understanding how it works, and then extending it in the future with other time-varying Cox proportional hazard models. So survival analysis is the Cox proportional hazard model is survival analysis techniques. It's basically looking at sensor data. So what it means is that if you take a chunk of records and then you put a stop to it at a certain point in time, the records that are not observed to have prepaid at that point in time are said to have been censored. So we can't really understand the behavior of those records. So therefore we have to ensure that we are able to model and taking that into account. And so these red dots are actually on the sample of 75, those that were actually prepaid before the censoring. I'm going to skip over these as well. This is my baseline model. So I used all of my variables. I created a lot of bins to see how they will perform, but ultimately my model really rejected several of those bin variables. And overwhelmingly, my model predicted that the balance bins are the ones that really weigh into the prepayment risk. And I'm still trying to figure out why that is the case. I would expect some credit score to be playing into that. So I probably would have to get back to it and see if there's any leakages or anything that's happening. I have time there. So additionally, on the Cox regression models, you can also use the baseline functions to really look at the baseline hazard rates and look at how the cohort behaves. For instance, the hazard rates tells you how much higher or lower the risk of prepayment is when compared to the reference rate. And the reference rate in my case is the 0 to 100,000 range loan bin. Okay, I do see the time. Here's my fit and my regression equation. And then At the top there, you can see the hazard ratios of how these loan balance bin were overwhelmingly weighing my model. And the concordant index is something that's used as a measurement. However, that value in the Cox world it should not be this high.
If you
And
could, I think if you could get to your conclusions.
Yep. I'm over, right? Time-wise? Yep. So my conclusion is that I need to take away and definitely understand how I can extend this model and figure out how to get the concordance index to get lower based on the data. So that's really it. And I have a few more slides here, but sorry, I didn't have a chance to cover it. Thank you.
Thanks. It's obvious you did a lot. Really appreciate the presentation.
Oh, thank you. I'm trying to understand it further. Thanks.
All right, Marley, and then Matthew.
Someone else is sharing, so I cannot share.
Bonnie, would you? Yep, thank you.
Okay, everybody. Welcome to Practical Pitch Prediction in Professional Baseball. I couldn't figure out a word that starts with P to use for baseball, such is life. Hitting the right arrow doesn't move me to the next slide. There we go. So why would you want to predict pitches, Houston Astros? Sign stealing has been common since the widespread adoption of the curveball in 1874. You look pretty ridiculous if you think a pitch is coming that's not the one that's actually coming, and you swing at it. Pitchers change speeds and also spin directions to try to deceive the hitter. And so if you know what's coming, you will have a massive advantage. There's already a ton of examples of people using machine learning to predict what pitch is coming. There's a few examples here. Support vector machines, neural networks, logistic regression, and all of these have a huge problem, which is, first of all, they rely on data that teams don't actually have access to prior to the pitch. For example, some of them rely on the speed of the pitch, which if you know the speed already, then you already know what the pitch is. And second, they can't actually be used to predict anything because you're not allowed to run a neural network in the dugout, and you have about 20 seconds between pitches to decide what's coming next. So that led to my research questions, which were, can decision trees create accurate pitch prediction algorithms that could actually be used strategically in a live game situation, either by memorizing rules on the part of the hitter or someone in the dugout providing clues or cues to the hitter? Can the models be improved by focusing on just pitch super types? There are many types of fastballs and many types of off-speed pitches, but they're broadly categorized into those two groups. And is there an advantage to considering a large number of features, or could we go back to what teams have been doing for decades and just look at what the count is and what the pitcher's typical patterns in certain counts are? So I picked 10 pitchers to use for this analysis. These 10 pitchers are the top 5 Cy Young Award candidates from each league in the 2024 season. Cy Young Award is the best pitcher in the league, so these are kind of the top 5 from each league. There are previous studies that say that there is no significant correlation between predictability and success, and so this shouldn't be an unusual subset of pitchers for the purpose of prediction. I used the PyBaseball library in Python to collect this data. I collected data on every pitch thrown by any of these 10 pitchers in the 2024 regular season. That returns 105 variables for each pitch, but most of these variables are not actually particularly useful. Many of them are information that teams don't have access to, and others include things like what the result of the pitch was or who was playing right field, and none of that information is particularly relevant to pitch prediction. So that got pared down to data related to the ongoing at-bat, the number of balls, the number of strikes, and the total number of pitches. Data related to the game situation, the number of outs, the inning, the lead for the hitting team, and the number of times the pitcher had faced the order, and the pitch type, which is the target variable. I modified some existing variables. For example, PyBaseball's data includes who the runners on first, second, and third base are. I converted that to just, is there a runner on first base, second base, or third base? hitter orientation was changed to a binary variable from a string, since it was always either R or L. And inning top or bottom was converted into, is the pitcher's team the home team or the away team? I also engineered some additional features of my own. Is it a double play situation? Does the pitcher's team have a safe lead, meaning if they give up a home run, they will still have the lead? The total number of runners on base, the pitch super type, fastball or off speed, what the previous pitch type was, and what the previous pitch super type was, both of which had to use one-hot encoding to be turned into numeric data for scikit-learn. Here's a summary of the pitch super types. Four-seam fastballs, cutters, and sinkers are fastballs. Everything else is an off-speed pitch. In a longer presentation, I might go through these in a little more detail, but I'm going to move on. So for each pitcher, the data was filtered to include only pitches made by that pitcher, split into a training and test set with a test size of 0.2, using a random seed of 42. Usually a random seed of 42 is Douglas Adams' Hitchhiker's Guide to the Galaxy reference, but in this project, it's a Jackie Robinson reference. Then I had to create a separate target variable for pitch super type, which is its own target variable, not its own predictor variable. And then create separate predictor training and test sets with just the count for the sort of control experiments. So here's kind of the pathway for that. We split into the training and test set. Then each of those is split into predictors and types. There's two different sets of predictors, one with all of them and one with just the count, and two different target variables, one that is pitch types and one that's pitch super types. So I'm training 4 machine learning models for 10 different pitchers, and we're predicting pitch types and pitch super types with decision trees from all variables and with just a count-based model using just the balls and strikes. To evaluate those models, I looked at accuracy and also weighted average F1 score, which separately calculates an F1 score for each of the classes in the target variable, and then weights them according to how many samples there are in the test set. So decision tree models, I used scikit-learn decision tree classifiers. I trained using 5-fold cross-validation instead of 10 because pitchers don't throw that many pitches in a year. There's only about 2,000 pitches per person. And so I felt that dividing into too many buckets, as it were, risked having each bucket be too small to be useful. I trained using a parameter grid, max depth 2, 3, 4, or 5. I didn't want to go above 5 because after that, the decision trees get complex enough that they're really not practically useful in a 20-second time window to look at and review them. And minimum samples per leaf, 5, 10, or 20. Again, didn't want to go much below 5 because if a pitcher has only encountered a situation twice, what they chose to throw those 2 times might not be particularly predictive of what's coming next. The resulting trees were then squashed down into a set of rules. So for an example, Tariq Skubal, his decision tree, which you'll see why I picked him in a minute, always predicts a slider against left-handed hitters, and against right-handed hitters, it predicts a 4-seam fastball if the previous pitch was off speed, and a changeup if the previous pitch was a fastball. So against lefties, he mostly throws sliders, and against righties, he is alternating 4-seam fastballs and changeups for the most part. Or at least that's the best the decision tree could come up with the limitations it had. The count-based models were a little different. I'm not going to go through all 10 pitchers, obviously. There's just no time for that. For the count-based models, the predictor variables, except for balls and strikes, are removed and then combined into a single variable that's just the count. So for example, 1 ball, 2 strikes becomes 1-2. And then I used a logistic regression model in scikit-learn to do these trainings, but because there's only one predictor variable, it just predicts the most frequent class for that predictor variable. I'm going to skip through these 2 results tables for each pitcher because there's summaries coming up. But one thing that's kind of interesting to look at here that I want to call out is Corbin Burns throws a cutter most often in almost every pitch, which is a type of fastball. But when you go to pitch super type, because he throws multiple types of off-speed pitches, although the cutter is the pitch he throws the most often, he throws off speed more often than fastball in some other counts. So I expected the super type to be more general, but it actually was able to pick up on some interesting patterns in the data that were not evident when looking at individual pitch types. Anyway, looking at results, we can see here accuracy and F1 score for the pitch type predictors. Notice that the decision trees do better than the count-based classifiers, but not by a lot, except in the case of Tariq Skubal, which is why I chose to emphasize his when I talked about it earlier. As for super types, they're even closer. Almost no difference between these predictors, so you really have to wonder if the complexity of the decision tree is adding very much. As for the type versus super type, in the decision trees, the super type classifiers are much better than the type classifiers, both in accuracy and F1 score. And that is also true for the count-based models. Again, the super type classifiers do much better than the type-based classifiers. So broadly speaking, the decision tree classifiers perform better. Different pitchers may choose different criteria for how to decide what pitch is being thrown. So selection of the appropriate model may be pitcher dependent. And the advantage that decision tree classifiers have over count-based classifiers is more evident in the type classifiers than in the super type classifiers. Had to speed through the ending there just a little bit, but thank you for the extra 10 seconds. And I'm going to stop my sharing.
Thanks.
Right, Matthew, and then Mikhail.
Okay, hello. So for my presentation, I'm going to be talking about building machine learning approaches to advanced care planning, billing in a multi-care healthcare context, or multi-center, sorry. So for the background, I'm going to be talking about what advanced care planning is and basically what we're going to be doing for this project. So advanced care planning, or as I'll be referring to it as ACP, refers to discussions that physicians have with patients for their end-of-life care conversations. So essentially when they're in situations where they have cancer or other types of terminal illnesses, and they may be in situations where they could not be able to communicate their wishes. So that's when physicians are going to be having these conversations. And this is good for the families and for the patients. And these conversations can typically involve living wills, MOLST or POLST forms, or DNR/DNIs. And ACP is typically built through certain criteria, a conversation regarding end-of-life goals or advanced directives. And these conversations should be lasting at least 16 minutes or longer. And then additional charges that are reimbursed are applied for every additional 30 minutes. And these are typically billed through certain charge codes that are 99497 and 99498. And that's what I'll more or less be using for the analysis, the presence of those charge codes. So let's think about why this is important. So a lot of research that's out there shows that ACP discussions reduce the burden of decision-making on patients' families, for one, and facilitate communication and transparency between both providers and patients. This also allows providers to potentially address and assuage anxieties that patients may have regarding their care or treatments, and just the progression of their terminal illness, because obviously that's going to be very stressful and just horrible for the patient in general. And also, ACP is pretty important for the healthcare system as well, because it adequately compensates providers for the services they're rendering. And it also serves as a quality metric for hospital services, so it's just another benchmark to show that hospitals are doing what they're supposed to be doing and giving these services they're supposed to be giving. But there are some barriers that go into advanced care planning, and that's where this project is coming in. So despite the importance of ACP, barriers in healthcare limit the administration of these types of conversations. Specifically, discussions can often be inconsistently documented within clinician notes. And providers often don't bill for ACP due to potential factors such as a lack of training for the subject matter or billing. Perceived ethical issues are even an aspect, but not really a focus here, or a lack of time to properly apply billing codes. And these barriers can hamper documentation and cause overlooks in quality metrics. So other research has identified ways to predict ACP content within clinical notes by using more or less manual chart review in combination with like logistic regression modeling. But the goal of this project specifically is kind of to expand on that and look for different types of unsupervised or semi-supervised approaches to detecting these types of discussions within clinical notes, and also to build supervised machine learning models to predict billing code application based on several factors, including patient demographics, clinical characteristics, ACP discussion probability as computed by certain methods, I'll just say cosine similarity, and also just the vectorized clinical notes themselves. So what are we doing here? So this is going to be a case control retrospective analysis. So we're looking back at patient records. And initially, it was from a subset of 20,000 records. However, I ended up randomly selecting 1,000 because of a lot of computational limitations. And 500 of these records had ACP billing codes applied to them, and 500 didn't have them applied. So I extracted records including demographics, such as you can see here, and a bunch of clinical characteristics and the application of billing codes. So this is what I generally did. I applied some natural language processing to the patient notes, such as cosine similarity, and I also applied a little Bertopic topic modeling to primary diagnosis, interestingly enough. And then I used a bunch of machine learning models such as logistic regression, SVC, as you may have learned about, and random forests. And I tried a little bit of XG boosting, even though it didn't go anywhere. But anyway, so I'm just going to give a little explanation of what cosine similarity is. So basically, this is just a way to vectorize and compare tokens based on their mathematical similarities. You can kind of see like a little example here, like hello world, and how that kind of relates to something like hi world. So these would probably have pretty similar metrics when compared to each other. So basically, I just applied that to a bunch of clinical notes out of the 1,000, and I compared them to a bunch of different phrases like, oh, advanced directives discussed or addressed, advanced care planning conversation, patient signed a DNR form, just to see if these types of phrases were being found within the clinical notes in any way. And then just because there's a lot of noise within the clinical notes, I ended up kind of aggregating everything to the mean top 5 cosine similarity values and also the maximum cosine similarity values. And these are basically typically measured on a scale of like -1 to 1 or something along those lines. Pretty standard scale. And then I just used a little Bertopic topic modeling using a Hugging Face transformer that was for clinical contexts on primary diagnosis, just because primary diagnoses can be pretty heterogeneous in terms of content. And I thought this could be an interesting approach to apply. So this is more or less what we have here. So these are the preliminary findings: the mean age, race, statistics, legal gender and sex, and insurance status. So this is what we have there. These are also the Bertopic topics that ended up being generated. So there were a bunch of topics related to sepsis or carcinomas, cardiac arrests, respiratory issues, and some other things. The most common one was sepsis and also hepatic carcinoma. And these are more or less the preliminary findings where I applied t-tests and also chi-square tests, or t-test or chi-square tests to kind of see if there were significant differences in billing code application and a bunch of these clinical characteristics. So for discharge disposition, which is basically, oh, were you discharged or did you end up expiring? There were no significant differences. I could have stratified this a little bit more, but maybe they'll do that in the future. And then I also looked at if there were any significant differences in charge code application with different charge codes, such as this very general one that's used for pretty much every type of situation where, speed this up, the person's admitted inpatient or outpatient. So this was found to be significantly different and used marginally more in cases where advanced care planning billing was applied. And then there's this one for inpatient or outpatient observation right here, which tended to be used less in terms of advanced care planning contexts. I'm going to assume because people are not getting discharged as often when they have advanced care planning conversations. But those are just some little preliminary findings there and not as much of the focus. So right now I'm also going to talk about the cosine similarity just to see how that performed. And I just ended up getting a little distribution here of the mean top 5 notes. And as we can see here, those who had an ACP encounter ended up having marginally higher cosine similarity scores compared to those who didn't. Same for maximum cosine similarity. It tended to be a bit higher for those who had ACP encounters versus those who weren't billed for ACP. And now what about the machine learning? So just to aggregate things and just summarize everything overall, metrics were commonly around like the 0.6 to 0.7 range for like their accuracy, precision, recall, and AUC. And I also decided to generate some feature importance too, just to see what features were kind of guiding the models. So cosine similarity was typically pretty important, and that ended up being a pretty good, relatively good considering the kind of adequate metrics. A pretty decent predictor of ACP conversations, which is what it should be. Clinical notes were also very important when they were vectorized. And terms like hepatocellular carcinoma or other types of cancers were pretty important for ACP, which actually makes sense because in the literature, ACP conversations tend to happen more for cancer-related visits. And similarly important topics included things like sepsis and respiratory failure, and also, as mentioned, cancer. So yeah, it all makes sense and is pretty consistent with the literature and what we see in healthcare contexts. Okay, never mind. There we go. Okay, and just to go a little deeper into the models, overall, recall tended to be the highest performing metric, usually performing around like the 0.7 range, indicating like a higher rate of correct identifications of ACP billing versus non-billing. But precision tended to be the lowest performing metric, unfortunately, averaging along the like high 0.5s, indicating a possible higher false positive rate of classification for these billing codes. And this is just a little table summarizing the metrics. As you can see again, pretty just basic, pretty adequate, nothing too amazing, which makes sense. And this is just kind of a list of the ROC curves. So in terms of the conclusions, just to kind of speed things up, unsupervised and semi-supervised predictive modeling approaches may be possible for ACP billing, but I would say that performance can be compromised just because of the unstructured and messy documentation and also the inconsistent billing practices that go into ACP conversations. So optimally combining manual review and using structured data may yield better performance. And future research should aim to construct models and algorithmic, I can't speak anymore, approaches to classifying ACP codes based on predictive indicators to enhance healthcare services for end-of-life care. I also made a reflections thing, but I think I'm out of time, so I'm just gonna not go into that. Thank you.
Thanks.
All right, Mikhail, and then Ron.
Okay, can you see my screen? Hello?
Not yet. It's I think it's processing.
Oh yeah. See my screen now?
Yes, now we can.
Okay, so I'll click. All right, so good afternoon, everybody. This is my project. So my capstone project is focused on like electricity demand forecasting and using machine learning. And right now, so basically for this project, I'm just focusing on like developing accurate and interpretable models for short-term electricity forecasting. So I used the three models I used XGBoost, SariMax, and hybrid approaches. So this project, the data set I'm using is sorry. They said I'll be using is I'll be focusing more on time series. So the motivation behind this I'll be using the Spain data set from like I'll be using the Spain data set, and then as everybody knows about the blackouts and stuff like that, the power outage that Spain and Portugal had this year, that they claim to be affected by temperature models. I wanted to use that kind of like as a basis for my project, because Spain has incorporated a lot of energy resources, particularly wind, solar, and on top of that, with the shift of like environmental, they're focused on environmental factors. Sorry, and I can't talk. I'm trying to say, and they're focused on more like be more environmental friendly, that they're trying to incorporate all these renewable energy sources. So I think the data set I focus on Spain is really a good basis to see how these models work and how to like have a reliable energy grid. So the objective for my research objective, like I said, I have three main goals. So I'll be comparing a range of models from statistical methods, the standard statistical method like SariMax, to modern machine learning. I'll be using XGBoost and kind of like hybrid approaches like ARIMA and also ARIMA plus neural networks. So I'll be focusing mainly on short-term forecasting, and specifically I'll be trying to predict electrical demand for like 24 to 168 hours, which is basically 1 week ahead. And this time is critical for like grid balancing, because like scheduling and contingency planning and stuff like that is generally done within this time period. So let me go to the next slide. So as I stated, the data I use for this study for NSOE database, which is basically the Spain database where they provide hourly electrical data from Spain. So I'll be using from like 2015 to 2019. Also, additionally, I'll be using weather data, such as from like including temperature, humidity, solar radiation, wind speed, and in order to like capture like environmental factors on electricity demand. So, and also, so for this one, I have over 35,000 hourly observations. So it's covering the span of 4 years. So, and in terms of the features that I used, I incorporated stuff like lags and more like 1 hour lag, 24-hour lag, 168-hour lags, kind of like these were kind of like crucial to achieving like the model's like high predictive accuracy. And so that's why I did. And I'll be using these are my variables that I use incorporated in my model. So I have time features, load features, rolling statistic, rolling mean and stuff like that, load differentials, and weather and generation inputs. So just to look at my data, so a summary of my data. So the box plot shows electricity demand by hour of the day. So this is aggregated across the entire data set. So each box represent load values in different given hour, and we can see like strong patterns and with a lot of the energy being used in the like middle of the day, 11 hour, like at 11 a.m., 12 a.m., that time period. And we can see like with load values and the lowest like in the early mornings around 2 a.m. to 6 a.m., right? So rising steadily through the day. So, and demand kind of peaks around this 9 a.m. to 10 a.m. 9 a.m. to 10 a.m. Time period. So it kind of like it's mimicking human patterns, because this is a time a lot of people go to work or get ready for work and stuff like that. So the data looks accurate. So yeah, and so in this study, like I stated, I'll be using like classical models like SariMax, CBAX, TBATS, STL, and ARIMA techniques. So these are these are classical models that are used also in industry. So and they're well known for like their interpretability, pattern, were strong, particularly strong when dealing with like seasonal structure, linear patterns, and stuff like that. And like SariMax captures like a lot of autocorrelation, seasonality, which while allowing for like external other variables like temperature and stuff like that. And the STL plus ARIMA decomposes the time series before modeling, and the TBATS is used for like dealing with multiple and non-integer seasonality. So, and then the machine learning, I'll use XGBoost. So apply this, so it's more like a tree-based algorithm. So it's kind of capture those non-linear relationships to my data, and the hybrid models, I said, ARIMA and neural networks. I want to combine them just to kind of see how those perform. So I'll be focusing on my primary models. So now, so before I did that, first thing I did when I incorporated like my time series, I did like stepwise variable selection. So as we discussed in previous slide, I kind of like did a stepwise regression to identify like the most relevant predictors because I didn't want to, since I'm using so much have so much observations, and the run times and stuff like that, I didn't want to use too much on my data set. So like I want to improve and also improving like the model interpretability and efficiency. So now so kind of like to capture like both like the temporal structure of like electricity demand and like the influence of other factors. And the SeriMax model like combines like autoregressive signal components, allowing us to model like time series. So I did try to select the 25 best variables in the stepwise regression. And I did also a auto ARIMA to kind of like get the best seasonal order. And so this is what I got for the order I got and the seasonal numbers I have. This is what I used. And in the next slide, I'll kind of like dive deeper into the trends and stuff like that. So this is my forecast. As you can see, the model performs relatively well. So this means so we include in the variables, and this means the model just doesn't kind of like rely on kind of like passive mind. It also incorporates kind of other external predictors. So I kind of tried to predict for like a week ahead. So on the right you can see like the streamers. So I kind of compared my predicted loads and my actual loads. So the model kind of captures the general trend and seasonality of the data, although it kind of like gets weaker as the days go ahead. But the performance is generally strong. So it's like the SeriMax model kind of like provides a reasonable baseline. It's particularly in capturing like daily patterns, but kind of like lacks for flexibility as we move ahead in the weeks, in the days, sorry. And this is my so for the wait, yeah, sorry. Yeah, so this is my ARIMA and neural networks. So to improve this model, I kind of combined ARIMA because it handles the regular patterns for trends and seasonality, and then I use artificial neural networks because it kind of could capture that non any complex and nonlinear behavior might miss. So I trained the model on like the past, like I said, for the past for a 7-day forecast on 68 hours, and then the the network I kind of use the network used for like 5 hidden units to check how well they work. I compared predictive values to the actual data using root mean squared and stuff. Oh, sorry, I didn't. Yeah, sorry, I thought I switched. So yeah, as you can see for my ARIMA ANN, it kind of captured it. It doesn't do well for the first 24 hours, but it kind of like adjusts. So I kind of like train the model to kind of like into so sorry. So yeah, as you can see, learning models it did what it can capture like bold structure and kind of like those uh like stochastic shifts and stuff like that. And you can see the accuracy is kind of reasonable. Not as well as the simple model as SeriMax. So this is just a check. And this is my XGBoost model that just looking at my XGBoost model. So after like I did like feature creation, I probably like correlation filtering, like to remove
Hey,
like variables with high
it's been
multi-
more than 10 minutes. I know you
oh,
really
sorry.
wanted to talk about like the explanation, so maybe you could get to like the Shapley and the conclusions and
Oh, sorry.
wrap it up.
Yeah. Okay. So Okay, so so this is what I did this is my statistics, what I did. So yeah, I did a Dibo Marino test. So I just like compared like my XG Boost model was my best performing model. And I just wanted to in this slide, so I wanted to do like a statistical method, like to determine whether the difference in forecasting is between two models is significant. And as we can see, the XG Boost model performs well compared to these other models, and the results show it using XGBoost is good for accuracy and reliable, and is statistically significant. So the limitations. So limitations in my work. So my conclusions. I'll conclude. So since I've been there, so as you can see, my XGBoost model had the best performance. With a root mean square error of 148 and a MAP of 0.5. So this ability to model nonlinear patterns and incorporate other features like lag and roller gave it a greater edge. And yeah, so what can be improved is like the rule of Parson, but like I could do like I could incorporate more other factors and variables and stuff like that, economic factors, kind of like to improve the model. And I did do a shape just to increase the interpretability for the XGBoost model, because I didn't want to like to do black box modeling just to see which variables were like affect the model most. So you can see I did the rolling means and stuff like that on the left side of the on the image you see here. So I'll conclude since I already spent way too much time here. So but yeah, but when I did for my research, the XGBoost model outperformed all my models that I did, even the statistical ones used in industry. So I'll conclude with that. But yeah,
Thank you, Mikhail.
yeah, I tried. I did much. Sorry, slide. Sorry.
Right. Ron, and then to wrap it all up is Nate.
Let me
You ready?
yep, give me 1 second. Let me know if my screen comes up.
Yep.
All right. All right. Hi guys. So for my final project, I decided to study the topic of pharmaceutical drug rebates, specifically for the time period 2013 to 2022. First thing I'm going to talk about are the price trends of drugs, what actually are rebates, different kinds of drugs, formularies, pharmaceutical entities, the workflow, price metrics, and my approach to the data analysis and the methodologies I used. So the first thing I want to talk about is how have overall prices for pharmaceutical drugs changed. From 2017 to 2023, the list prices have risen on an average of 15%, so about over $590 per product. And the average increase from 2021 to 2022 was 11.5%, or about $172 per product. Half of these increases exceed the rate of inflation. And since 1980, the adjusted spending on retail prescription drugs has risen 7 times. Adjusted for inflation, retail prescription drug spending has risen from over $100 in 1960 to $1,147 in 2021. So you can thank that for why your prescriptions are getting more expensive. When it comes to how America consumes pharmaceutical drugs, we are clearly on top. We are outperform almost every single country in terms of spending and sales in pharmaceutical drugs, exhibiting one of the top growth rates at 11.5% as of 2014. Going specifically, what exactly is a rebate? A rebate is essentially a retrospective discount that is provided by the drug manufacturer to some third-party payer after a patient fills a prescription for a drug. This rate is usually not public. It is negotiated between the drug manufacturers and the third-party payers, such as insurance companies and pharmaceutical benefit managers, also known as PBMs. We're going to come back to PBMs. The actual price that a PBM pays for a drug is the list price minus that dollar rebate value. The PBM pays some portion of that rebate value to the insurance company, and then it puts that money towards plan beneficiaries, which essentially lowers the cost of insurance premiums and deductibles for when people go to a pharmacy to get their prescriptions filled. It does not directly lower the price that you pay for your prescription because patients will pay based on the list price of the drug. This is rarely disclosed publicly, but current market conditions have a benchmark around 10 to 15%. Price transparency is clearly it's a particular challenge under current market conditions, especially for generic drugs where prices vary considerably. So what are the different types of drugs? We have brand name drugs, which are drugs that are sold under a specific patent protected name or trademark. And then we have generic drugs. They are identical in every single sense to brand name drugs, but the difference being that there will generally be multiple suppliers. It's going to have a lower cost, but there's going to be less rebate value on them. So for example, if you were to go and purchase a brand name drug, you're going to pay more for it, but you're more incentivized to do it because the PBMs indirectly make them more profitable. And the other type of drug are something called specialty drugs. These are drugs that are complex, they treat rare conditions, they require special handling, storage, and they're very expensive because they're usually the only type of drug that treats a specific kind of condition. Specialty drug spending has risen by 43% from 2016 to 2021, about $300 billion, but only 2% of the population use these medications. Now, the way that companies and PBMs decide how much a rebate value will be for a drug is based on something called a formulary. A formulary is a tiered list that is negotiated between the PBMs and the insurance companies, and they decide what is the proportion for a drug's rebate list price that will be reimbursed. This requires a bunch of contract negotiation, but the main takeaway is that drugs in lower tiers will cost less and those in higher tiers will cost more. So what are the multiple entities that are involved within the realm of pharmaceuticals? We have manufacturers, which are companies that develop and produce the drugs. Wholesalers are distributors that they will buy drugs in bulk from manufacturers and they sell them to pharmacies. We have plan sponsors such as employers, government agents, or unions that fund health insurance plans for members. We have patients who are the end consumers who buy medications. Pharmacies are just where you go, you fill a prescription, and it buys drugs from wholesalers, and it gets reimbursed some dollar amount by PBM or insurance. And PBMs are third-party administrators between health insurers and pharmacy that manage prescription drug benefits on behalf of the insurance companies and plan sponsors that they do business with. They negotiate the prices, they create those formulary lists of drugs, and they work on behalf of their clients to lower the prices that they pay for drugs. They negotiate drugs by reducing prices, and they just negotiate discounts. Some PBMs actually may own or contract with other pharmacies to offer a deeper discount. And this is a workflow that essentially shows the entire process. There's a lot of interaction. I'm not going to spend too much time to this because this is a doozy, but this essentially shows all the different costs and all the different interactions between each of these entities. Now going to the metrics of drugs. The true price of drugs is rarely made public, and when you go and purchase something, as say, for example, a car, you understand that there are different kinds of costs involved. There's sticker prices, there are invoice prices, production and research costs, sales price. Drug pricing is variable based on the type of transaction. It could be wholesale to pharmacy, pharmacy to payer, beneficiary to insurance, pharmacy to Medicaid. And the first one I want to talk about is something called actual acquisition cost. It's the price a pharmacy actually pays to buy a drug from a wholesaler or manufacturer after any discounts or rebates. It's the real cost that the pharmacy pays. It's not a list price. It's not a suggested price. States often use AAC to set a Medicaid reimbursement rate. The estimated acquisition cost is just how much a state Medicaid program will pay to buy a drug, usually based on other pricing benchmarks that I'll talk about in a second. This is used when the AAC is not available, and it helps determine how much Medicaid should reimburse a pharmacy. NADAC, or the National Average Drug Acquisition Cost, and the benchmark that I'm going to use for my analysis is, I think, the optimal one because it's based on nationwide survey data by the Center for Medicaid Services, or CMS. It looks at the actual invoice prices paid by retail pharmacies to wholesalers, and it reflects real-world acquisition costs. It's updated regularly, and many programs have shifted to NADAC as their new pricing benchmark. Then we have average manufacturing price, which is used to calculate inflation rebates and reflects the average price paid by wholesalers for drugs that are sent to retail pharmacies. We have the average wholesale price, which is one of the most commonly used benchmarks and sometimes referred to as the list price of a drug. Although it's very controversial because up until 2009, PBMs were found to have been price gouging and basically inflating the AWP, which they used to essentially profit gouge and raise prices, hence why everything has gotten so expensive. A bunch of third parties such as AnallySource, Medispan, and First Data Bank published this price, but has not been done since. And the last one I want to talk about is WAC, or wholesale acquisition cost. This is not the actual transaction price. It does not include discounts and rebates, and it excels when assessed by benchmark criteria for accessibility, simplicity, and the low cost. And on the right is just a workflow of how all the costs factor into one another. So this is just a practical example for how drugs would interact with all these financials for brands and generic. I'm not going to go into it because of time limits, but you can see that there will be different costs for insurance. There will be different costs for at the pharmacy, different kinds of discounts based on if it's a brand or a generic. And we're going on to my data analysis and methodology. So I started by looking at the Clinical Calc website, which sourced from the Medical Expenditure Panel survey. And I looked at the top 200 drugs from 2013 to 2022. And I acquired all of their brand names and generic names. And I scraped this data and compiled everything into a comprehensive list. So I had the drug names, the brand names, and the generic names. Of course, there will be some overlap. So I decided to keep this granularity. There will be many drugs that essentially would roll up to one another, but I had different metrics for each of them. So I did not want to roll them all together. And I did this, and then I searched through the FDA's data set to acquire something that is called an NDC, which is a national drug code. It's essentially a new identifier that serves as a universal identifier for drugs. I searched in proprietary names, non-proprietary, and substance names. And then I created two different functions. There we go. I created two different functions to sort through the names. I created an exact function match and I created a fuzzy match to try to see, okay, which NDCs are associated with drugs. And this gave me two different kinds of NDC groups. I had the exact matches and I had fuzzy matches. The blue ones being fuzzy matches, they were overly flexible for different drug names, some of which would receive thousands of matches, some of which would receive a few. There were a small handful of drugs that received 0 matches and needed to be manually set. I did this by manually searching through the FDA's NDC data set, and I needed to clean that up. As you can see, once the computation had finished, a list of originally 200 drugs had expanded into a couple of thousand of names, which expanded into a list of over 40,000 different NDCs for each of the drugs.
Hey, if you could really get to like the modeling and conclusions, it's been more than 10 minutes.
Okay, I will fast forward through. I'm going to fast forward to, but essentially I connected to the API to pull the NADACs, which is essentially the publicly classified metric that I could use to pull the drugs. I did this by splitting my over 90,000 different NDCs into groups of 1,000. I performed API calls in batches of 1,000, and overall it took over 27 hours to run. But by the end, I had averaged everything out to an annual basis so that I had the average NADACs for each NDC. There are existing relationships for comparisons for NADAC to the AWP, and there is an existing relationship between the AWP and the WAC rate. There have been other studies on it. And additionally, there are studies based on how much a rebate value will be contained according to WAC, which takes me to this tool, which has been, let me see, hopefully this shows up on my screen. Can you guys see the website?
Yeah. Did you make this?
I did.
Nice.
Thank you. So this is essentially, I created based on my NADAC extract and from the extracts that I did from the ClinCalc website, I was able to pull the number of prescriptions, the number of patients for drugs. I'm able to select metrics such as the average NADAC, the average wholesale price, average wholesale acquisition cost, and the rebate min, average, and max values. I'm able to, let me go to a smaller subset. This tool allows you to search for the 200 different drugs. I'm able to break it down and facet it into the different NDCs that are contained for each drug. And I can see all the different metrics. I can specify which NDCs I want to look at. This also has functionality to export the data, export plots, and also to specify if I want to just look at brand and generics. As I briefly showed, the brand and generics will have different rebate values.
Could you get to the main point and then conclude?
Yeah, the main point is, here it is. I have the actual rebate value estimates for the 200 drugs, which is not something that is generally publicly available. My suggestions for future analysis, just contract with one of the many different sources out there that actually publishes accurate AWP and WACs for all the different drugs, because this is just an estimate. There was a tool that does provide this, but it's no longer public. It's locked behind an annual subscription. Yeah. Any questions?
Thanks. That website looks really sweet.
Yeah. Thank you.
Very neat.
All right. I think I just turned on subtitles. All right. Give me just 1 second to start my timer. I think I can keep this under 10 minutes.
Right.
Let's see if we can do this. So my presentation.
We're not seeing your slide deck.
No. Stop my. Let's see. Okay. All right. Can you see my slide deck?
Yeah. No. All right.
All right.
The last slide. Okay, now we're good.
Okay. My capstone project was to see if heterogeneity testing can improve provider feedback. So historically, surgeons haven't received high quality feedback. And part of my work, I work on a quality assurance initiative that is trying to change that. So what you're seeing here is simulated data for a graph of complication rates for a specific disease site resection. If you were a provider logging in, your bar would be in red. All the other providers in your service would be in blue, and the gray vertical line would be the average of the surgeons. On the right-hand side, you have a number of options that allow you to stratify your rates to answer questions more relevant to your specific practice. You know, for example, the options at the top, if you're a surgeon who performs mostly or exclusively minimally invasive procedures, you could limit the cases to just minimally invasive procedures. So all of these options are chosen by the service, and you know, to allow them to dig into their data. But just with these options alone for these complication rates, there are 72 different graphs that a provider could potentially review. And that raises a problem. So you have this paradox of options. You potentially are in a situation of information overload, and it's been found that as people are exposed to more information, their processing capacity can be exceeded, and actually their decision making degrades. The other issue is this issue of choice paralysis. If a provider or an individual is presented with too many options, sometimes they choose to do nothing, and that is not what we want providers to do with this feedback. And so we believe that a solution would be to add a flag to these outcome graphs that would give the provider additional context. It would tell them whether the variation they were seeing on a specific graph could be due to chance alone. And then hopefully enable them to focus on the graphs that are of greatest interest. So this involves heterogeneity testing. So heterogeneity tests evaluate whether the variation that is observed in the effect sizes are larger than what would be expected based on the sampling variability. So this is most commonly used in meta-analysis. So we're, rather than studies, we're applying it to surgeons, and rather than study of participants, we're looking at specific surgical cases. So we're interested in instances where you would reject the null hypothesis that the outcome rate is the same across all surgeons and that variation could be due to chance alone. So here, we have one of the most common heterogeneity tests. This is the Q statistic, which is the weighted sum of the squared differences between individual surgeons and the pooled effect. So before we can start talking about heterogeneity testing, it's helpful to talk about the difference between fixed effect and random effects. So these are two frameworks, modeling frameworks, that are used in meta-analysis. Fixed effects models estimate the average effect of the included pool of studies, ignoring the presence of heterogeneity. So in essence, these pink squares are the individual study effect sizes, but they've all been they've all been shifted so that the black dot is the average, theta is the average effect of all these studies, excluding any interstudy heterogeneity. But a little more interesting are random effect models that assume a distribution of real effects, where you have a mean of mu and then a variance of tau squared. The between study variation is a random in a random effect model can be the result of multiple forces: study design, cohort makeup, when the study was done. In our instance, that tau, so we're looking at adjusted rates that have been adjusted for patient characteristics or patient risk. So we're hoping that that tau is actually the variation caused by the surgeons. And just to tie back to the other model, if tau is equal to 0, then you just have a fixed effect model. So before we can start looking at the heterogeneity test, we have to look at the literature. And there's this issue, the limits of heterogeneity test power. The power of a statistical test is its ability to correctly reject the null hypothesis. The literature, there are instances where the heterogeneity test may be underpowered, where it's prone to a type 2 error, so a false negative. And those are situations where they're saying when there's less than 16 study participants, or sorry, when there's less than 16 studies in the meta-analysis, or when the sample size in the studies are less than 500. There's this other issue where if the sample sizes of the studies vary greatly, and it's been found that in most instances that is the case. So 10% of trials or 10% of meta-analyses involve 2 studies, one that is 10 times larger than the other. And that is actually what we see in the data. So the data that I'm using were 6,700 surgical resections for primary lung cancer done between 2013 and 2024. This data set includes patient demographics, age, BMI, sex, risk factors that are used for risk adjustment, things like comorbidities, peripheral vascular disease, renal dysfunction, diabetes, and then disease characteristics like the path and clinical stage of the disease, the type of procedure, so the extent of the resection. And the outcomes that we're looking at are all binary outcomes, things like return to OR, complications, readmission within 30 days, 30-day mortality, positive surgical margin. So if the surgeon left some of the tumor in the tissue in the body, and ICU admission. So, the data that I'm using is not publicly available, so I wasn't able to share some summary statistics, but the mean effect size for each of those outcomes and the variance is what I used to define my simulations. So I start with just defining the parameters. So things like the number of surgeons, I'm really running out of time. Number of surgeons, number of effect size, number of cases. I pre-allocate the data. Then I simulate my delta tau, which is the difference between the surgeons. I update the effect size for individual surgeons based on that delta tau, simulate the cases for the individual surgeons, and then concatenate the surgeon's data, perform my heterogeneity test, and then I calculate my alpha. So the first thing that I looked at was this issue of number of surgeons. So here we have a graph where the effect size is 0.3. So you say like an event that happens 30% of the time. Tau of also 0.3, so a variance of 0.3. And we're looking at the number of surgeons versus the heterogeneity test power. And it's really interesting. All it takes is 4 surgeons, and then the heterogeneity test power is over 90%, which is a positive sign. So the next graph here, we're looking at the average number of cases that a surgeon had in the simulation. And so each of these simulations we ran for each combination of parameters, we ran 5,000 times. So we have the number of cases on the x-axis, and then again, the heterogeneity test power on the y-axis. And here we're looking at over a range of values of tau. So starting at 0.05 all the way up to 0.3, which in our real data was kind of the range that of variation that we saw in the actual data. And you can see that the test power improves as the average number of cases improves, and that there is definitely, the larger the tau, the quicker you reach that asymptote. So the other question we were interested in is if there is difference in the number of cases. So on the left-hand side, we have the same number of cases on both the right and left side, 900 cases. So we have 5 surgeons with 180 cases, and on the right-hand side, 4 surgeons with 50 cases and 1 surgeon with 500 cases. And you can see that there is a degradation in the power of the heterogeneity test. You still have, for high levels of tau, so tau, you still have performance around 90%, but at lower levels of heterogeneity, the model performance really drops. Why is this not? All right. So in conclusion, where are heterogeneity tests appropriate? So in our circumstance, it doesn't look like we need 500 cases. It looks like even 100 cases, an average of 100 cases per surgeon is enough to give us performant heterogeneity tests. Under 100 cases, we might want to evaluate. We also saw that they recommended 16 studies or 16 surgeons. We saw that we had relatively strong performance with just 4 surgeons. If there is an imbalance in the surgeon case count, the power might be diminished. So looking at that average case count might give you an overestimation of the actual power of the study. And not shown, but separately, evaluated, we don't see an inflation of the type 1 error rate across the parameter grid that we search. So that doesn't seem to be something we need to worry about. So you would expect that about 5% of the time you would see a positive heterogeneity test result when there in fact wasn't heterogeneity. So there are some limitations. I only looked at binary outcomes. We also have linear and survival models that were not evaluated. There are many heterogeneity tests. The Cochrane's Q is kind of the most well documented and I think easiest to implement. So that's why the approach I used. And then the other, there are many data generation models that you can utilize. So for example, I used one where the within surgeon variance was set with a standard deviation of 1. There's others that modulate that and can give you slightly different results. So there's, you know, more simulations that could be done. Yeah.
Thank you.
12 minutes. Ugh, shameful. We're all getting watches for Christmas.
We have so much to talk about, not enough time.
All right, questions?
When are our final papers due? I don't remember if the deadline is the 20th or the 21st.
Yeah, I had similar question as well. I just wanted to know how to submit them as well.
Submit to Brightspace. If you have a lot of code and data, actually technically you can upload a lot to Brightspace, but you may also provide a link to a GitHub repository and a repository where your data is stored if it's data that you're allowed to share. But make sure that your work is somewhat reproducible. Otherwise, you should have, depending on how you compiled your report, make sure to turn in at least one iteration of it that is readable no matter what. So a PDF, a doc, something like that. And if you generated it using your report using Markdown, also submit the Markdown, because then some of the code could be seen. As far as due date, if you're yeah, like after the 22nd becomes like really, really hard to turn everything around. So try to get everything in by then. At least for people in my section. I don't know. Like that's maybe like the last, like I don't want, there's no like last, but like if you want to graduate, I have to have time, you know, to finish reading your paper. So yeah, keep that in mind.
So George, do we, so if I have a Word, then I just convert it to PDF?
If a Word document is fine, I can read that.
Oh, okay.
I mean, so technically speaking, like sometimes Word versions can be inconsistent, and the PDF is like generally speaking more reliable. But a Word document is fine.
Okay. So I have a Word. I can submit that in, and then do you also need? I was trying to run my Markdown, and I had some issues, but so within the Markdown, if I was to run it, like if I pull in all my model files, etc., like is that what you want to see, or the code? For instance, my code.
Like yeah, however you organize your code. Like I'm not sure what method you use, but if you have it in scripts, if you have it in like Python notebooks, if you have it in a Markdown file, whichever I can I can live with.
Okay, so if I had like 4 scripts, just turn in the 4 scripts and then the Markdown if it's running properly.
So let's say you know, I imagine you have some code that generates your figures and generates your summary stats. At a minimum, like package that together in a little file and send it. If you also have the code that you use to process your data from scratch, provide that too. But if not, it's okay.
Oh, right. So for the code, I think I can, I don't know if I can share that one, but if I can share it through the, I think I can send you a private repo of
Okay. So
Google.
yours is a case where the
Yeah.
data set is proprietary. Don't worry about it then. Yeah, I don't need to like I mean, I guess you could, if you're comfortable sharing a private repo, sure. But don't do anything that gets you in trouble. Like,
All right, when I said, do you have any questions?
Thank you.
I was
I have
meant,
questions.
do you have any questions for the presenters?
I had a question. And maybe if you guys have questions for your classmates, you can go first. But if not, I have one or a few.
Can
Wait,
I ask
I
a?
think Nate has a question about paper, probably.
No, I've been chomping at the bit to ask Matthew some questions
All right.
because
For it.
I was like, oh, Matthew, we need to like exchange contacts or something. I feel like we're
Yeah,
we're
I mean, you work at
dealing.
Memorial Sloan Kettering. I work at Jamaica Hospital. We
Yeah.
technically have that link there already.
Yeah, no, but I was like, we're working with very similar data and actually answering similar questions. I was involved in a project where we were looking at whether or not people were receiving, for example, like chemo regimens close to end of life, like essentially like unnecessary treatment, as they were kind of navigating the issue. But my question was actually about, I've worked a lot with billing data, which seems to be where you're pulling this. And I find billing data often is not granular enough because
Yes,
it has been
100%.
collected for reimbursement purposes, not really to diagnose or document diagnoses or even procedures for that matter. So I guess I was curious if you ran into any of those situations where you didn't have enough information, enough kind of granularity based on the billing information you're using.
Yeah, this is actually something I wanted to mention in the reflections, but I didn't have enough time to. I'll just like briefly say it now. Like there were a lot of issues when it came down to the fact that billing is granted on the encounter level within Epic, as far as I can tell. And
Mhm.
two, there is that matter of, like you said, kind of the reimbursement matter. So sometimes there will be a lot of inconsistencies for one. Two, I mean, I'm able to kind of base things on the service date too. So, but I have to ignore things like post date, let's say, or date of application. So I'm kind of using the billing code more or less as a proxy for an indicator of advanced care planning, because that's not readily entered into these types of Epic software or EMR software. Although there are sometimes very inconsistently used diagnostic codes, but that's a different matter. So I found it as a decent proxy, but it is definitely very much imperfect and, like you said, not granular enough. So I 100% agree with that.
That was actually, wasn't that one of the reasons you wanted to look into the notes? It was because quantitative data weren't granular enough. And so you thought maybe that the notes would provide you with more information. Is
Yeah,
that
it was also definitely to see like if I could link the notes as a potential indicator. Like one of the use cases of the project was more or less to say, okay, we can use the notes to more or less determine when these types of billing codes should be applied, because they're very inconsistently applied for a lot of reasons, because the physicians just either don't care enough to apply them, even though it's a quality metric, or they don't have the training, or they might have some ethical issues with applying them manually. So that was one of the aspects of this, the idea that's okay, so maybe there's more of an automation angle for this type of situation. But it also goes into, yeah, I want to see how the granularity in the notes to see if they serve as good, decent predictors, which is definitely another angle of this type of project.
By the way, so just since maybe this is the last class you guys are ever going to attend in the program, we have a LinkedIn group. Feel free to join it, and then you will have contacts with each other, and you won't have to worry about the fact that you lost it or look somebody up. So I just like to pitch it. It's, hopefully like this, this school continues to build its like network of alumni. That would be good if you could participate in that. I had a question for Nate.
Hmm.
So I'm super curious if like I don't know if surgeons like specialize on like one procedure or do many different types. Did you consider whether it would be beneficial or possible to like estimate like a single parameter and have that influence have that like model success rate for multiple procedures, like to pool data across different procedures?
Um,
Or if
you know,
like somebody is good at one surgery and bad at another, or if that's a more realistic model.
there, at my institution, there tends to be a lot of hyper specialization. So, it's really the younger surgeons who tend to do multiple resection types. And so then I think you've got someone who's still in their learning curve. Who you're
So could you use this to like winnow people into different specialization?
I mean, I think people just kind of land, find their sweet spot. I think, I think it happens just in its own natural course. It's tricky. So I'm giving feedback to surgeons, and I don't know if you've talked with surgeons or dealt with surgeons. They're not really looking for guidance. So
No,
so it's more like they decide which outcomes we present, and they decide how it's stratified and how it's risk adjusted, and it's really up to them to kind of do with it what they will. But I don't know, that's a really interesting question, whether or not there's even like an opportunity for yeah, fellows or younger surgeons to like review their rates and see like across, I think if I'm understanding it, like across disease sites, and see like, oh wow, I might have a gift for this type of resection. I don't know, like in that, like maybe that's what I should specialize in.
Cool.
I have a conceptual question for you, Nate. What is
Yeah.
the purpose of the feedback? What do you intend or hope that surgeons will do with it?
So there's two things. So there is the service average, and they see where they fall, and maybe even the service average is too high or too low for a specific outcome. So it's saying, well, how are we doing as a team? And then it's saying, well, within that rate, kind of where do I fall? Like how much so what does our service average look like? How much variation is there? Because ideally, regardless of who you go see, your positive margin rate should be the same. So it's like, how do we reduce that variation? And, as an individual surgeon, like kind of where do I stack up in that variation?
Okay, cool.
So yeah, I mean, but this is not as probably Matthew or other people can attest. So, clinicians also, we use Epic. There's a lot of reports generated, and so people are kind of overloaded with feedback opportunities. And so I thought providing this heterogeneity test would maybe allow them to say like, oh, this is a graph that I should care about, or this is not something that I need to worry about.
I see. Yeah. Cool. Thank you.
I have a question for Marley. I saw you like warming up your arm as if you were going to pitch, but my question is about hitters. So I do, and maybe you don't know, but like what? So what is a hitter? What would a hitter do with like a probabilistic form? Like, I imagine if you told the hitter to pitch, like it's gonna be a fastball, they would like do something. But generally speaking, if you gave them, like if you told them like we think 70% fastball, 30% like off speed, would they find that useful, or is that already like?
So
do you know like how hitters like decide? Because they can change their minds. I imagine they were reacting to something.
Yeah, so I'm really bad at it, so I'm not like a good source for how professional hitters approach this. But I think that, broadly speaking, the trend in Major League Baseball is toward kind of selling out for whatever's most likely and just going like, okay, if it is a curveball, I'm going to hit it to the moon. And if it's not a curveball, I'm going to look really dumb. And kind of, you'll see a lot of people complaining about things like 3 true outcomes hitters, which is walk, strikeout, or home run. And basically what that is, there was a time where people were embarrassed to strike out. If you grounded out, you weren't embarrassed. But if you struck out, that was really embarrassing. And the sport has really moved away from that and a lot more toward people going, well, ground out, strikeouts, the same effect on the game, but hitting the ball to the moon has a very different effect on the game. So I'm just going to try and do that on every single pitch and guess at what pitch I think is coming. And if it doesn't work out, then I'll try again next time.
So
Sorry, go ahead.
So you could, like, if you could tune the model to provide a probabilistic forecast, then you might be able to say you might be able to give them like an expected, like, what's the best thing to do, like, by expectation. Like, maybe it's like a 50%, maybe it's like a 40% chance of fastball, but like home run would be very beneficial. So like, you just go for it. Or
I see what you're saying. I think that realistically, actually, the guy. So I play on a baseball team. That's why I'm holding this.
are you about to go to a game?
No. I just
Okay, good.
decided that props are important. But the guy on my team who is the best at it, like, he pitched for Princeton. He was, could have played in minor league baseball at least. When he's giving feedback to other people on the team, one of the things he says is like, it's good to show what you're working on during workouts, and you're like, you're trying to hit the ball at like a very specific angle or whatever. But in a game, when you're taking live swings, I shouldn't be able to see any of what you're working on. It should all be automatic. And I think that, sort of to what you're saying, I think that it makes sense in theory, but realistically, changeup is like as much information as a guy facing down a major league pitcher with a 6-pitch arsenal. I think, like, the Astros cheating scandal, which provided them a huge advantage, was they had a guy who would whack a garbage can with a stick if it was not a fastball. And that was complex enough that it provided a pretty meaningful advantage. But I don't think that hitters can actually realistically.
No, I just meant like, I didn't mean to give them like a fancy forecast. I meant like lie to them possibly if it would be like slightly more beneficial, like if it's a close case and
Gotcha.
Like swinging at a fastball would like score 4 runs.
Yeah, well, I think
like it happens 30% of the time or something.
Yeah, well, I think the lie there is to just say like fastball.
Yeah,
like,
that's what I meant. Yeah, you would just say you would say fastball when it was like a 30% chance or something.
Right. Just sit on a fastball, and if it's a fastball, then we score 1,000 points, and if it's not a fastball, then I apologize and give you a different pitch next time.
Okay. That really helped me understand. Thank you.
Yeah. The origin of this, actually, my initial interest in this project was watching a Yankees playoff game, and the pitcher threw a curveball and it missed, and threw another curveball and it missed, and I said, now he has to throw a fastball in the strike zone and Urshela's going to hit a home run. And then he threw a fastball in the strike zone and Urshela hit a home run. And I thought, I bet there's probably some math here and not just like, it's not just all intuition. But there's no question in my mind that Gio Urshela was standing there thinking, fastball. If he throws a really good curveball, I'm going to look really stupid, and I'm okay with that, because if he throws a fastball, I'm going to hit a home run.
Can I ask one more like last question for this?
Oh yeah, sure.
Like, have they like had an major league hitter like watch a game and like predict the pitch? Like, I'm curious how accurate that would be.
I'm going to send you a video. Greg Maddux had the nickname The Professor because he was this very cerebral guy. He was a pitcher, and he had all these famous quirks, like that he intentionally let a guy hit a home run in the regular season because he knew he was going to face him in the playoffs. And he knew that the guy would be looking for the pitch he'd hit a home run on, and he would throw a bunch of pitches that looked like it, but then move the other direction. And he struck him out in the playoffs when it mattered. So he had like all this stuff. And there's a video of him and Barry Bonds rewatching an at bat where they faced each other from like 20 years earlier, and they both watched the first pitch, and then it cuts to Barry Bonds saying, okay, so the cutter beat me inside, so he thinks I'm going to speed up, so he's going to throw a changeup away. And then it cuts to Greg Maddux saying, the cutter beat him, so he's probably going to speed up, so I'm going to throw a changeup away. And then it shows the clip of he throws the changeup, Bonds knows it's coming. He's able to not swing at it, even though normally you would swing at it. So they're actively playing chess while they're in the batter's box in that way. And some people are really good at to your question about have they made people watch it. Some people are really good at talking about it. Not every professional athlete is good at talking about athletics. But the people who are, they've done some pretty cool interviews with them. I'll send you the Maddux Bonds interview because it's very neat.
Thank you.
I just have a comment for Molly. So Molly, I found your presentation and project fascinating. I love music, and it was just interesting of how you thought through the process and the design. And I'd love to see your paper because, I was just wondering what happened to America, like the music in America recently, like, the songwriting, the genres, it's all changed really. I've been listening to music from back in the funk and the soul and the R&B, and now it's like they talk about in the US how they only want a certain type of looping, right? Like it's very simple music. And then I've been following some K-pop, and then in K-pop they've been actually attracting American songwriters over there, and they've been going over there for 20 years now, like because they prefer more musical elements, and they want specifically more complex. And then the songwriters were saying that they would love to work on stuff like that, but they can't anymore in the US. So it's kind of cool that you're thinking through this kind of a model. I would just wonder how yours fits in with Spotify or something. It would be, I think there's a real use case of how you're looking at, but you're looking at different things, but still, it's kind of cool. Thanks for bringing that idea. And just because I was reading about it, I was fascinated by yours. Thanks.
Oh, thank you. Thank you for sharing the related things you've been learning about too. That sounds really fascinating. I appreciate it.
Sure.
I actually have a follow-up question for Molly, kind of based on what Banu was just talking about, which is, I'm curious, as someone who's like tried to get Spotify to play my music for more people, did any of your research turn up like, does Spotify or any of those platforms use sentiment analysis as part of its recommender system? Is that something that kind of came up?
It didn't come up.
Gotcha.
I would imagine they do based on what I see in my own curate, like the titles that they give playlists, you know what I mean? Like it feels like they definitely know like what is going on in the lyrics.
Gotcha. Okay.
But I didn't research that specifically.
Cool.
Just real world. So.
I had a question for Banu.
Yeah.
I was wondering, so it sounded like you were surprised at the results of the Cox model, that the balance was the most predictive variable for whether there was prepayment risk. And I'm curious, like, if you have an explanation, like, why do you think that might be? And then how did it affect the risk? I assume like the lower the balance was, the more prepayment risk, or
the higher is
the
more
higher the balance.
Yeah, basically.
Oh,
yeah.
okay.
So basically, my understanding was looking at some research. Credit score should play a role. I was looking at Moody's research, and so higher credit score means higher balance loans, and because they're more credit worthy. So credit score didn't even play a role in my data set, and it's probably because of the way I was merging the 3 files. I think I should really be running it from a sense of like a like the entire, like a machine learning across the 120 million and really learning from there. It's probably because I'm merging 3 different vintages in different time frames. I don't know if I'm
So
learning.
you don't trust it. I see.
No,
Is
I
the
do. I
vibe I'm
mean,
getting.
I mean, the balance definitely does play a role in the prepayment for sure, but I was trying to figure out why the credit score didn't, you know, what was going on with the credit score. So that's something in the future I'd like to extend it and see what's happening with with that credit score.
Banu, I actually have a follow-up question there. Is if you refinance your mortgage, does that count as like a prepayment?
Yes. In essence, you're refinancing and it becomes a new loan with a different
Gotcha.
rate.
Gotcha, because you pay off the balance of the
pay
existing
off and you
loan
move
with
to a
the
new
new.
loan, right?
Okay.
But yes,
That kind of makes sense then, because like all the effort to refinance, you only do it if there's going to be a big payoff, right?
Right.
right.
Higher loan balance, higher probability
And
of doing it.
and it occurs to me that people with higher credit scores are more likely to want to refinance because they're more likely to get favorable terms on that loan.
Right. That's right. That's standard. So it is the way its behavior is accurate in the sense that the balance loans are more influential on the risk. But my question was more about, is the interaction between the two, how am I really gonna extend the measurement of it? So maybe I have to create an interaction term and see in the future to model it. Okay, thank you.
I had a question for Nate, actually.
Mm, okay.
So I was pretty interested in your modeling approach with the Cochrane's Q, applying that to more of like a single sample type of approach when that's typically for meta-analysis approaches and aggregating effect sizes. I was wondering what your thoughts would be on if you think introducing a mixed effects model or a generalized estimating effects equation would work for this type of approach.
So I wasn't, maybe I wasn't clear in my simulation. So I am simulating a range of, so I'm not doing a Cochrane's Q on just one surgeon, but on a, just on my graph where you have a whole service shown. Essentially, I'm doing it on a number of providers between 2 and I think 15. I landed on the fixed effect. So this was something that like I kind of struggle with, just because the rates we're showing are adjusted rates. And so in theory, the only thing that's not, like in theory, the only thing that's not been taken into account is the actual surgeon, the impact of the surgeon. And so that's why I was like, well, this tau kind of serves as, the between surgeon variance kind of serves as like a estimator of the surgeon effect. So that's like kind of how I landed there. I'm not there in short, but that was like my thinking in using the fixed effect or sorry, the random effect. I hope that answers your question.
Yeah, no, I think that makes a perfect sense for that approach. I just definitely thought it was interesting for the application of that type of model. Very cool.
I just want to say, Mikhail, I loved your presentation. I fell in love with time series analysis last semester, and my original plan for this capstone project was to do time series analysis, and it didn't pan out. So I give you serious props for
Yeah, thank you.
finding
Trust me,
finding something to apply that.
Yeah.
it took the runtime for this was I did way too much. I did 4 years and just running in R. I've been up all night. That's all
Oh,
I'm gonna say.
jeez.
Running this. But I liked it though. I was trying to see combine some models just to see if it improves and but honestly the simpler models are the one that perform the best honestly in this my time series. But thank you though.
Yeah.
I enjoyed your projects.
I wanna second what Nate said. As soon as I saw your research question, I was like, oh hell yeah, we're gonna get some time series tonight.
I want to third that because I thought it was fascinating. Because last semester we learned from Jeffrey Emmons' course, like those ARIMAs and the moving averages, and really seeing the application. I was like, wow, this is something that I'd like to learn a lot more of. So
I'm
thanks,
taking
Mikhail.
I'm taking
No
that
problem.
series class with Jeff Neiman right now. It's really interesting.
Yeah, yeah. So seeing it on the slides was great.
Oh, thank you.
Have you been following the Spain, like all the debates about what happened in Spain?
Oh.
All the
Yeah,
energy social media people are like fighting with each other. It's very funny.
yeah, I've been following it. But I've been hearing the main sentiment is that it was a lot of weather stuff. So I try incorporating that into my project. But honestly, the data was kind of hard, especially because you had to get it from a Spanish website. So I don't know Spanish, so it was tough. So yeah, I had to the temperature, at least the temperature data and stuff like that. What was hard, but like I think there are like other clean data like on Kaggle and stuff I got, so that was a little bit easier for me.
Cool.
He hasn't been able to follow it because his computer's been busy running 36 hours of R code.
Yeah. Our power grid thankfully hasn't collapsed as a result.
Yeah, trust me, this is not fun. It was not fun at all. But I learned a lot.
It was really cool.
Thank you.
By the way, that's like a really rapidly growing area. Like, if you're interested in like power system models, because I mean, I feel like the power grid is the most complicated thing that humans have ever built, and now it's getting more complicated with as we add new technologies, and yeah, there's
Yeah,
a huge
yeah,
amount of demand, I think.
yeah, it's growing because they're incorporating like a lot of renewables into into the grid. So yeah, it's complicating a lot of stuff, and there's a lot of factors that go in. There is actually an industry that they not a segment in like cause I just uh got a off job at National Grid, and they do a
Ah,
lot of the thank you
congrats.
yeah thank you they do a lot of the modeling, I think SCADA and stuff like that. So they do like a lot of like grid reliability. So like, and you could use like the data to do like a lot of scheduled maintenance and stuff like that, like or preventative maintenance. So it's good. I wanted to do an anomaly detection, but that was too much. I couldn't do that. No way. But yeah, so I kind of wanted to incorporate that, but there's a lot of stuff going into that, like uh on the like grid reliability research and all that.
How do you think the dependency on the renewable energy would change the modeling? And
Uh, it could because sometimes it depends on a lot of environmental factors. Like sometimes I think incorporating a lot of like spatial data because sometimes the you might have not have you might have cloud cover or stuff like that. It could affect the solar reading and stuff like that. So if like maybe I don't know how they split that up, but maybe sometimes one of the grid might rely heavily on solar. So if that's lacking, it could kind of like affect the stability of the grid, all of that. So yeah, So it really can affect it. But that's why I picked Spain, because Spain is more like 50% of renewables in incorporate in their grid.
Mm,
We're not really there yet.
right. I have solar panels. Am I contributing?
Yeah, I mean solar panels. So for my undergrad, I did stuff like that. The energy looking at solar panels and stuff like that. But it's kind of like a heavy upfront cost, and then you had like I said, it mainly relies on like a lot of spatial data, like cloud cover and stuff like that. So if you're not, it really depends, because you have to do like GIS, like kind of like GIS spatial analysis, to, like depend on see which areas are more optimal and stuff like that for like
Mhm.
yes, it's a lot.
Is it true that if you have like enough energy being generated by solar panels, that like if you contribute, you start getting tax cuts?
I think so, but you do. It's a heavy. I think in New York there's a program where they pay it, but like once you integrate it, you have to kind of like keep it. If that's what I remember. But
I think
honestly,
it's a super controversial issue depending on where the place is.
yeah. But I honestly, in my honest opinion, I think the best the best form of energy is definitely going to be nuclear, 100%.
Oh,
And and I think there was research on, like, I understand with the atomic waste. I think there was research on like a bacteria that could eat the atomic waste, but that's the only like clean energy that really doesn't have a lot, like, doesn't affect anything else.
Yeah, but you got to get Suleiman's. I don't know if you were here for Suleiman's project. You got to get
Yeah,
those like mega project costs under control. Like,
yep.
yeah,
because I feel like I agree with you, but like when like the last time we tried to build a nuclear plant, it like bankrupted the company. Like,
yeah. It's
there's
very
it's
expensive.
just like that's a problem, right? Like, but
Yeah, it's very expensive. It's very
but
expensive because you can't. It's like you have to have specific zoning and stuff like that, and you have to have a lot of regulation and stuff like that. So that's what makes it that expensive.
well, ultimately,
But
I think like each technology has a strength and a weakness, right? Like solar's strength is it's not a mega project. You can just like pace them. The weakness is it's complex to deal with in the grid. Nuclear is like once it's into grid, it like lasts 100 years. Is super simple, but to build it, it's like a mega project, and you have to like solve that problem, which is
Yeah,
a problem in like everything in society right now.
Right.
Um,
I think they're
so,
turning
like,
on the 3 Mile one, right? Nuclear
yeah.
reactor to fund Microsoft's grid
Oh,
for
geez.
AI. And that was something that I think, Mikhail, maybe you've seen that, but that came up in one of our posts, actually, in one of the classes, about the project cost accounting related to that nuclear reactor and how it was built originally, right? And now they're turning it back on. I think they're trying to re-engage that, right? That's what I heard. So
I think it's not the unit that melted down.
it,
I'm pretty sure, or the unit
it's
that
the
had
one
an
next
issue.
to PA. They said it
Yeah,
was
it's
not.
they had like a number of I think they had a number of units there, and it's like
Oh, okay.
it could be mistaken, but it's definitely one of the 3 Mile Island units.
Okay. Yeah, yeah. No, I was just wondering about, like, I think the article was related to Harvard, like something totally separate from decision tree, I think, around project build of that reactor, like of that facility back then. And what's involved with that kind of a plan kind of setup. And so when Mikhail said it, I don't know how many of those we have, and the capital expenditure that goes in with it to build those up.
yeah. That's the main constraint with nuclear energy. It's definitely the regulation and just the cost. But in my opinion, I think it's still worth it in the long run because it could power a whole like city basically
How
for 100
long
years.
is this long run?
Like I said, it's a while. It can definitely power it more than the like wind, offshore wind and stuff like that, because that also comes a lot of like environmental risks and stuff like that. So that's why I think it's better. Like nuclear is better, but it definitely could take a while. It could power it for a good while.
I watched the Chernobyl miniseries like 2 weeks ago, so I need like another 2 weeks before I think nuclear power is a good idea again.
You know what was funny? The reactors next to Chernobyl kept running and were only turned off very recently. It's kind of crazy.
Yeah.
It's like almost unbelievable, but I think they were the same type too.
Yeah, well, they said they were in the miniseries. That doesn't mean that
I'm pretty
that's
sure.
true, but
it's kind of like I think there might still be a few of that insane design that are out there. But that blew my mind when I heard it. It was because the entire area was like turned into this exclusion zone. But then like there was a room with like stuff operating like basically next door, and people were able to work there. So I know I've never quite been able to like understand what was the deal.
That and I think Fukushima, those are two. The whole sentiment of nuclear, like, it's just a whole negative just because of those two. But I still think it's relatively safe.
Yeah, and those were extenuating circumstances, essentially, just rife with safety violations and just poor design. I'm pretty sure, but in general, it's just a fairly safe power source.
Yeah,
its biggest problem is definitely the cost.
Yeah,
sure.
Oh no, yeah.
I'm looking at the time. We are 24 minutes over. For those who need to go, just some final thoughts. You guys are welcome to stay and chat longer. But great job on your presentations. If you guys are graduating, will we see you at a graduation? Yeah, awesome. Stay tuned on Slack because we're planning this we're informally planning a get together Thursday evening, the day before graduation, and so just keep your eyes on Slack for more information about that. We're being kind of last minute on the planning. If you have any ideas as to where we can hang out Thursday evening, please share your ideas. I am a little rusty in terms of New York City hangout places because I haven't been there, living there for over a decade. So you guys, some of you, all of you, a lot of you are still living there. So give ideas, and I hope to see you guys in person. And I bet George shares that sentiment as well.
Yeah, I wasn't sure you guys would want to invite us, but
yeah.
I was trying to like exclude myself to not be.
No. Jason also wants to celebrate with you guys. No, I think the purpose of doing this Thursday evening hangout is to hang out with us. So, of course you guys can hang out by yourselves if you want, but.
Gosh, I haven't been to the city in years. So
are you coming?
I'm gonna try. I'll try. There's just so much going on with the kids, so we'll try, Angela.
All right, that sounds good.
They're also, just to put out there, not like I have a 5-year-old, I can't be hanging out with people, but there's around the Barclays Center, there's some actually really good food. So people either before or after, if you want to get lunch, do a little research, it's become more of a destination than it was, Angela, when you lived here. Like Park Slope is right there. It's got good food. Crown Heights. I mean, there's also like right up Atlantic. There's a bunch of fun restaurants.
Oh, cool. So you're thinking maybe after graduation might be a better time?
Oh, I'm just saying, like, if you're there and you get through the graduation, whoever's there might want to maybe not race out.
Why not?
Stuff to do. So.
How well conducted are these graduations? Because I was not fortunate, it turned out, not to be at Lehman College's graduation last year, but it was like 6 hours long.
So yeah. I don't know what to expect. I haven't been to one of these before, so
you're changing my mind about signing up to go to graduation.
I know that like
no, it was
you
great
have to show
and short
up at
and
7
fun.
a.m. and then they say they're going to be done at 11:30. So I don't know when the participants like have to show up, but I believe I got the impression that I had to be there at 7 a.m. or something like that. You seem pretty early,
Right.
but you may know something different.
In the chat, Ron suggested we all break out our Letterman jackets, which
Yeah. You guys have Letterman jackets? Do they offer one? Do they sell one? A CUNY SPS Letterman jacket? We don't have. Do we have sports teams?
No idea.
We can letter in sports analytics. How about?
yeah.
Yeah, you guys.
We should just go all the way and put mathletes. Just get
Yeah.
mathletes jerseys.
Mhm.
Just get jerseys with some
Yeah.
types of Greek symbols on them to
Yeah.
symbolize our data science pursuits.
Can do like
Yeah.
elite code or Kaggle. I don't know if anyone does those.
Before the opportunity is gone, so Yanyi, you used to be a New York City high school math teacher,
Yes,
and what do you do now, if you don't mind my asking?
I am a full-time student right now. Cause I took like 5 courses per semester, and
Too
it's just too
many.
much. Yeah.
Ah,
Whoa.
Congratulations.
Yeah.
that's
Congratulations.
Oh my
amazing.
gosh.
So did you do the entire program in 1 year?
Yes.
Wow.
Wolf.
Your Sundays must be miserable.
Kind of.
But then now you're done. That contrast. You're not going to know what to do with yourself.
Are you did you find this year more fun than a year of being a high school math teacher?
Well, definitely.
Okay, well, there you go. Yeah, just to be clear, guys, it's not like Sunday nights are great when you're a teacher either. Just
Yeah.
True.
Yeah.
True.
Are you ready to get out of the system, Marley? You're teaching, and Molly. Or are you good there?
No, I'm not. I'm not good there. I'm very much getting out of the system
All right.
as soon as possible.
yeah, we're losing Molly, who is one of our best teachers and a tremendous asset to our department. And my guess is that I'll be able to hang on for another year or two before her absence makes working there so much less fun that I want to go do something else. But like, I don't know. I feel like sometimes it's kind of taboo to talk about it this way, but I admit that for me, it will partially depend on like what kind of money I can expect to make elsewhere.
That's pretty
No,
obvious.
that's
No, that's
important,
not
yeah.
like.
When you're a teacher, like there's a little bit more of like a weird stigma attached to leaving to go make more money.
Well, okay, but
yeah. Anyway,
you can go like make some money. Then you could go teach again. Like
that's true. Yes.
Like,
but yeah, I mean,
useful.
there's like,
This is New York City.
yeah.
I don't like.
In my head, I kind of have a threshold for like, there's an amount that I would plan to leave for and an amount that I would be like, all right, I'm submitting my notice for. I don't actually know what those amounts are,
Yeah.
but
I was
like they
gonna
do,
ask you.
they theoretically exist. And
Oh.
I have no idea what the job market for someone with my background and now a data science master's would really look like. So I don't really know what to expect on that front. But
So are you gonna like apply for like things that look cool and just like play it by ear?
yeah, I'll probably apply for like a few jobs at the end of this school year, mostly to force myself to get like, because if I'm like, oh, I'll do it at the end of next school year, then I won't get my portfolio and my GitHub in order. And I'll like say, oh, well, I'll do it next year. And then like next year will roll around and I still won't do it. And so like,
Yeah.
I think that I'll probably try to apply for a couple this year, mostly to force myself to like finalize a resume and get my portfolio in order, and then see how next school year goes and kind of go from
By the
there.
way, there are lots of sports analytics jobs. Like those
That's true.
probably like those may have the same issue with teaching jobs though. Like they expect you're doing it because you love it and they don't pay as well. I'm guessing, and they have crazy hours. So yeah, but I've seen plenty.
There are multiple people on my baseball team who, because we play in Central Park, so like it's just kind of people from all over the city. And there are multiple people who like there's a guy who worked for Major League Baseball, like he was on the MLB app team and did like some project management stuff for them. There's a guy who works for Fox, like Fox Sports, just people who are interested enough in baseball to play adult recreational baseball tend to be in jobs that are related to it in some way.
That is interesting.
Yep.
That makes sense.
I have to drop, guys. Thank you so much.
Thank you so much.
Thank you,
And,
Really
Marley.
enjoyed your
um,
presentation.
Yeah.
Thank
Appreciate
you.
it.
And Marley, if you'll see something in Synchrony Financial, feel free to reach out to me because they're pretty good and they're, out there in the city.
Sorry, say the name again.
Synchrony Financial. I don't work there now, but I have contacts there. So, they're the consumer finance. So if you're looking around,
Cool.
I think but their entire analytics is moved to Hyderabad now in India. So it's just the model management teams are spread out, but still it's pretty decent, like the company, the values they have. So,
Cool. Thank you.
all right. All right, cool. Thank you.
All right, thank you.
Thank-
Bye.
Real quick, Molly, where are you posting your project? Like, is your or let me rephrase that. Is your presentation going to be posted anywhere?
Like my GitHub.
Okay. No, I just know some people who are really into music and would probably find that that was a really novel presentation.
Oh, thank you.
So
Yeah, I hadn't really thought about it.
yeah.
But I'll have to
Okay.
like post all the code and stuff, I guess.
Yeah.
I'll have to submit that. So
Hi,
Yeah.
Matthew.
yeah.
See you in a couple weeks.
Okay.
All right. Have a good night, everybody. Take
Good
care.
night.
Have a good night.
Everyone's dropped in.
Good night.
Good night.
I'm also gonna have to
Yeah.
go to bed. Thank you so much.
Good night. Go to bed.
Bye.
Goodbye, all.
Good night. See you
Bye-bye.
tomorrow.
That's right.
Yeah, like literally the first thing we're gonna do tomorrow is have a department meeting that we're both in.
I'm sorry, or not sorry.
No, it's as department meetings go, it's not bad. Thank you both so much. This has been great. I'm sorry to ask the question again, but I think the due date that's on Brightspace is the 21st. That's definitely fine.
I don't know. I feel like I might have put different due dates than Angela, so our sections might not be the same. I'm not sure which one you're in. I can't remember.
I think Marley's in your.
I'm in yours.
Then yeah, whatever it says is fine.
Okay. Because it's like I just have to go through and like do all my citations. Like I don't
Yeah.
write in my citation. I have to like fix the citations, double check all the numbers in the tables, and I'm like,
Yeah.
I could stay up really late tonight trying to do that, or I could promise to get it to you by next week.
That's
And-
fine. It's fine.
Okay.
I'm behind on grading, so it's fine. Don't worry.
Heard that.
Yeah.
'Tis the season.
Yep.
Yeah.
All right. Well, thank you both so much,
Thank you.
Have a great night.
and
Yeah.
see you at the thing.
Yes.
Yeah. Pick it. We gotta pick a spot.
Things.
Yeah.
Yeah. All
All
right.
right. Bye.
Bye, George.
Enjoy the
How
rest
you
of your
feeling?
conference. What's that?
Hmm? How you feeling? Are you better?
A little bit coffee, but I'm not sick anymore. I just have like some residual
That's good.
residual coughing. I'm
All right,
totally
that's good to
better.
hear.
So
Yeah. How's your wife?
she is not sick anymore, but has like 100 times worse residual coughing.
Ugh, yuck.
It's, unfortunate, but it's yeah. Hopefully she'll be feeling better soon.
All right. All right. Get well.
I will.
Continue to rest.
Yeah.
You guys.
I'll see you around.
I see ya.
Bye.
Good night. Bye.